Okay, I'm gonna shoot a relative compression test on a different type of scope. I'm gonna do it on my Pico scope this time. This is the new 4000 series. Very nice scope. I'll show you a couple connections and then we'll go to my smart board and I'll show you the rest of it. Alright, for starter compression, or for relative compression, starter current, I'm going to connect an amp probe. In this case, I'm using my, my Pico's high amp probe. And this is a 600 amp clamp. It is polarity sensitive. There's a little arrow indicates direction of conventional theory current flow. And I'm clipping that on my battery cable that goes to my starter. So that's going to measure starter current. And then the second thing I have connected is I have a sync probe connected to my number 6 plug wire. I'll see if I can show you that here. My number 6 plug wire. I have just a little RPM pickup type probe that connected to my number 6 plug wire. This is a conventional system, so this guy is going to give me an impulse every time the number 6 cylinder fires. I'm going to get an impulse from that, and that's going to coordinate my amperage waveforms from the starter. It's going to coordinate my cylinder firings, coordinate my compression from each cylinder. I'll be able to tell which cylinder is which. Okay, I'm doing a relative compression test with a Pico scope. I'm going to click on my Pico 6 icon on my desktop. This is a laptop-based scope. And I'll walk you through the settings with this. Channel A, that's where my amp clamp is set. I'm going to set this to my 600 amp current clamp. And this is a nice feature because the scales will be set up for me. I don't have to do any math or conversions. So 0 to 600 amp is the screen. Actually, it goes minus 100 to 600 amp. So any negative amperage, I'll see it. And then the second channel, I have my sync probe connected. One of the things I do generally before I set this one is I'll adjust the scales with the car running. So I'm going to start the car real quick and we'll set that one up. So my second channel is set to a plug wire, so I want to turn this on. It's going to be voltage. Let's see what it looks like. And there's a line going across the screen. That looks pretty good. Let's up the time base here and see a little bit more of it. And that looks great. The only thing is that red line going off the screen. Again, this is a sync probe. So each of these high red lines would be the plug firing on that particular cylinder, which we're connected to number 6. That's important to remember. But I like to set it up with the car running because then I can get my sync probe coordinated properly and be happy with the settings on that. Now we're ready to do the compression test. All right, for this one, this is another nice feature of the Pico. What I'm going to do is I'm going to set up a trigger and I'm going to do a single shot. And I'm going to set this trigger on channel A and I'm going to put it about 200 amps. And what that's going to do is it's not going to draw the picture. And we'll take this up to a 500 millisecond per division screen. We can zoom on this later. But what this trigger is going to do right here is notice the scope's kind of waiting for it to cross that line. So this blue trace, I'm triggered off the blue channel. It's not going to start drawing the picture until it hits 250 amps. It being on a single shot, what that's going to do is that is going to freeze the picture for me. I'm over there at the car cranking. I'm not over here to stop it. It'll stop it automatically. Very nice feature of the Pico. And I'm going to crank the car. I'm going to give it a clear flood crank because I need the ignition system to be active. I'm not going to disable the ignition. Pedal to the floor. Notice the picture's frozen, single shot. You see this little icon down here at the bottom turned red, so it stopped it. And a nice feature with this tool is with a frozen picture, I can zoom. I can actually filter it frozen too, which is cool. If we take this amp pattern, which has some hash to it, we can actually throw a filter in on that. You can see a lot more clear those relative compression humps, if you want to call it. So very nice looking picture. Another thing that's really nice is we can zoom on any part of this we want to. And I'm just going to grab just a section of it. And what we're looking at is our synchronized relative compression waveform. And if you remember, we connected this second channel right here. We connected this to our number 6 cylinder. So what we need to do now is we need to figure out firing order for this car. This is my number 6, this red line, and this is the number 6 again. And we got to figure out the cylinders in between. So let's look that up real quick. All right, so we looked this up on Mitchell. VIN 3.0 firing order on a V6, as you can see, is 1, 2, 3, 4, 5, 6. So a very easy one. So then we go back to our scope, plug in our numbers. If this is number 6, our firing order is 1, 2, 3, 4, 5, 6. That's pretty easy, isn't it? So the next one here, this is 6. This is 1, 2, 3, 4, 5, and then 6 again. Relative compression, synchronized, using a low amp probe and a sync probe on a plug wire. So next thing I want to do is I want to take the spark plug out, and we'll take a look at what that looks like with the plug removed. All right, what I've done, I have removed one spark plug, and we're going to retake this capture. I'm going to hit the space bar, and it's ready to go again. See a little green light down here is lit, and my trigger single shot once again. I'm going to go clear flood mode crank. I have one spark plug removed, simulating a dead cylinder. I really like that filter. That makes it really nice and clear, doesn't it? Ignore the other little red spikes. They're nothing. One of the things about doing this kind of testing is know what to look at, know what not to look at. We're worried about the big red spikes because that's the one connected to the number 6 cylinder. And, you know, we can zoom back in. We can stay out. Doesn't really matter. I guess I'll zoom in on it again. And we'll just zoom in on a little bit of this. And what we're looking at is, again, this is number 6. I know that's the number 6, so I know this blue trace and that hump right there is the number 6, right? Because that's the one I'm synchronized to. And the spark's going to occur at top dead center. And from there, firing order. So this is number 6, and we said that our firing order is 1, 2, 3, 4, 5, 6. So this is going to be 1, 2 is missing, 3, 4, 5, and 6 again. So where's my dead hole? Number 2 cylinder has no compression, and that is the spark plug that I removed. Is the number 2 spark plug, first one on the front bank, 246 on the front cylinder head. Number 2 cylinder, no compression. Synchronizing it using secondary ignition. In this case, what's different about the last one was a waste spark, and we had to worry about the high-low compression exhaust, where this one's conventional ignition. And on the number 6, it's just going to fire. It's going to be a high spike every time. 6 on compression, 6 on compression. So all the way across the screen, this is the number 6 cylinder on compression. Zoomed out. Starter current synchronized with an ignition firing. And check out how hot the amperage is on the starter on initial crank. Right? This one's over 600 amps. Guys, that is normal. And this all has to do with counter electromotive force, DC electric motors. But that's a much nicer relative compression waveform, clear than I got on the Varus for sure. So that's it, relative compression with the Pico.